Let us solve another question related to the calculation of losses. The question was asked at 2015 for 16 marks. Let us go through this question. A pre-stressed concrete beam 250 mm wide and 360 mm deep, pre-stressed with 10 wires of 35 mm square, each area located at a constant eccentricity of 60 mm and carrying an initial pre-stress of 1250 Newton per mm square. The span of beam is 12 meter. Calculate the percentage loss of stress in wires if the beam is pre-tensioned, and second one if the beam is post-tensioned, using following data. The given data is Young's modulus of steel is equal to 210 kilonewton per mm square. Young's modulus of concrete is equal to 35 kilonewton per mm square. Relaxation of steel is equal to 5% of initial stress. Shrinkage of concrete is equal to 300 into 10 raised to minus 6. This is for pre-tensioning. 215 into 10 raised to minus 6 for post-tensioning. Ultimate creep strain is equal to 45 into 10 raised to minus 6 pre-tensioning. 22 into 10 raised to minus 6 for post-tensioning. Slip at Anchorage is equal to 1.25 mm. Frictional coefficient for wave effect is equal to 0.0015 per meter. You have to find out all these losses and make list of all these losses related to the post-tensioning and pre-tensioning beams and find out the percentage loss. Let us solve this question. So first you have to sketch the cross-sectional view of this beam. Okay, first you have to sketch the cross-sectional view of the beam. Okay, so this is the cross-section of beam with 250 mm wide. Okay, and the depth of beam is 300 mm. The depth of beam is 360 mm. Sorry, it is 360 mm. Okay, so this is the siege of concrete. Also you have to sketch the longitudinal section of the beam. Okay, so this is the siege of concrete and span of beam is 12 meter. Okay, the tendon is having constant eccentricity. Tendon is having constant eccentricity of 60 mm. That means tendon is straight. Okay, with a constant eccentricity is 60 mm. Okay, you have to also show the wave of a tendon in cross section. The eccentricity is 60 mm. Okay, pre-stressing force is provided here. Let us assume that one end is fixed. So you have to find out the all losses with respect to the given data. Okay, so first loss is frictional loss. Okay, so we know that the frictional loss is calculated using the formula mu alpha plus kx into initial pre-stress. Okay, again the mu alpha term is 0 because tendon is straight tendon. Okay, the value of K is given in question. It is 0.0015 per meter. Okay, so let us calculate the loss. Okay, this term is 0 plus 0.0015 multiplied by what is x? X is the distance from jacking end where the maximum loss is developed. So consider this is jacking end and this is the remote end. Okay, always at remote end the maximum loss is developed. Okay, so this is the remote end. At this end maximum loss is developed, so the x is nothing but the span of the beam. So directly have to put here 12 meter. Okay, and initial pre-stress is mentioned in question. It is 1250. Okay, so what is the frictional loss? Let us calculate the multiplication. It is 0.0015 multiplied by 12 multiplied by 1250. So this loss is 22.50 Newton per mm square. Okay, now let us calculate the next loss, anchorage slip loss. Anchorage slip loss. Okay, so anchorage slip loss is del A into ES divided by span of the beam. Okay, so the anchorage slip is given 1.25 mm multiplied by Young's modulus of steel is 210 into 10 raised to 3. But in question the Young's modulus of steel is given 210 kilonewton per mm square. So you have to convert this value into Newton per mm square divided by span of the beam is 12 meter. So you have to put this value in mm also. Okay, so what is the loss of pre-stress? What is the loss of pre-stress due to anchorage slip? 1.25 into 210 times 3 divided by 12,000. Let us check this value. 1.25 into 210 into 10 raised to 3 divided by 12,000. The answer is 21.87 Newton per mm square. So this is a loss due to anchorage slip. Okay, now you have to find out the third loss. Shrinkage loss. Okay, shrinkage loss. So this loss is calculated using this formula: shrinkage strain multiplied by Young's modulus of steel. So shrinkage strain is given in both the condition of beams. For pre-tensioning the shrinkage strain value is different, for post-tensioning the shrinkage strain value is different. So first find out for pre-tensioning members. So this loss is pre-tensioning members. Shrinkage strain is given 300 into 10 raised to minus 6, 210 into 10 raised to 3. So the value is 300 into 10 raised to minus 6 multiplied by 210 into 10 raised to 3 The value is 63 Newton per mm square. The value is 63 Newton per mm square. And for post tensioning members, so this loss is 215 into 10 raised to minus 6 multiplied by 210 into 10 raised to 3. Okay. So for post tensioning members, this value is, it is 45.15. It is 45.15 megapascal. Okay. So in this question, we have calculated the two values of shrinkage loss, because the shrinkage strain is different for post tensioning members and for pre-tensioning members. Okay. Now the next is creep loss. Okay. So in this question, the creep strain is given. Okay. So you have to use the formula which having a creep strain value. So epsilon creep multiplied by ES multiplied by FC, using this formula to find out the creep loss. Okay. So let's first find out the FC. FC is the stress in concrete at the level of tendon. So this stress is developed due to the direct pre-stressing force plus the bending moment developed due to the eccentricity of a tendon. Okay. So in this question, the pre-stressing force is directly not given. So to calculate pre-stress multiplied by area of wires. So the pre-stress is 1250 multiplied by the area of wires are, okay, so 10 wires are given and each wire is having area 35 mm square. So 10 wires, number of wires multiplied by area of one wire, it gives the total area of wire. Okay. So 1250 multiplied by 10 multiplied by 35. So the answer is 437.5 into 10 raised to 3 Newton. That means 437.5 kilonewton. Okay. So let us calculate the FC. So there is no need to find out the FC average because the cable is straight cable. So FC is equal to pre-stressing force is 437.5 into 10 raised to 3 divided by cross sectional area of a beam is 250 into 360. Okay, plus 437.5 into 10 raised to 3 multiplied by the eccentricity of a tendon is 60 mm divided by Z is nothing but I by Y. So it is 1/12 BD cube 250 into 360 cubes. This is the moment of inertia with respect to the x-axis, and Y is the distance of wire from the siege of concrete. It is 60 because you are calculating the FC at the level of the tendon. Okay. So the first value is 437.5 into 10 raised to 3 divided by 250 into 360. So let this value is 4.86. Okay. Next is 437.5 into 10 raised to 3 into 60 into 60. Okay. Divided by 1/12 into 250 into 360 cube. Okay, so this value is 1.62. okay, let us check this value. 1 by 12. okay, 1 by 12 into 250 into 360 cube, okay, divided by 60. So only this value is 16.2 into 10 raised to 6. okay, so 437.5 into 10 raised to multiplied by 60 divided by 16.2 into 10 raised to 6. Correct, this value is correct. So FC is equal to 4.86 plus 1.62. so the FC is 6.48 Newton per mm square. So if you get FC, you can easily find out the loss due to creep. Okay, so the creep loss is, okay, creep loss is for pre-tensioning first, because the creep strain is different for the pre-tensioning and post-tensioning. So the loss is for pre-tensioning, the creep strain is 45 into 10 raised to minus 6. ES is 210 into 10 raised to 3 multiplied by FC. The value of FC is 6.48. okay, so the value is 45 into 10 raised to minus 6 multiplied by 210 10 raised to 3 multiplied by 6.48. okay, so value is 61.23. the value is 61.23 Newton per mm square. okay, so this value is for pre-tensioning. For post-tensioning, because the epsilon creep value is different for post-tensioning, so it is 22 into 10 raised to minus 6. 210 into 10 raised to 3 is the ES, and 6.48 because the formula is epsilon creep into ES into FC. 22 into 10 raised to minus 6, 210 10 raised to 3 multiplied by 6.48. the value is 29.93 Newton per mm square. So we have calculated the creep loss. The next is friction loss is already calculated, anchorage slip is calculated, shrinkage, creep, these losses are calculated. Now lastly, you have to find out the relaxation loss. Fifth one is relaxation loss. So this loss is 5% of initial pre-stress. okay, it is the 5% of initial pre-stress. okay, so 5 divided by 100 into initial pre-stress is 12. Initial pre-stress is 1250. okay, so this value is, okay, so it is 62.5 Newton per mm square. okay, and last loss is elastic deformation loss. okay, so the sixth is elastic deformation loss. So this loss is calculated as M into FC. So M is equal to, it is the ratio of Young's modulus of steel divided by Young's modulus of concrete into, we know the value of FC. Okay. So Young's modulus of steel is 210, Young's modulus of concrete is 35, FC is 6.48. Okay. So 210 divided by 35, this value is 6, multiplied by 6.48, it is 38.88 Newton per mm square. So total all losses are calculated. Now list out all losses related to the post-tensioning and pre-tensioning, and finally to find out the percentage loss. Okay. So first you have to list out all these losses. First for post-tensioning beam. Okay. And next is pre-tensioning beam. Okay. I'll write down all the losses. Okay. So first loss is frictional loss. Okay. So we know that the frictional loss is present in post-tensioning. The value is 22.50 is absent in pre-tensioning. Okay. Second is anchorage slip loss. Anchorage slip loss is present in post-tensioning. It is 21.87. It is absent in pre-tensioning. Okay. Third one, elastic deformation loss. Elastic deformation loss. So if the wires are tensioned one after another, this loss is present in post tensioning. So assume that the wires are tensioned one after another, because there is no any special sentence is mentioned in the question. Okay. So this loss is absent in this post tensioning, but pre tensioning this loss is present. Its value is 38.88. Now further losses are present in both the cases. Okay. So fourth is shrinkage loss. So shrinkage loss for post tensioning, it is 45.15. For pre tensioning it is different, it is 63. Okay. Creep loss for pre tensioning and post tensioning having different values. For post tensioning it is 29.93. For pre tensioning it is 61.23. Okay. And last sixth one is the relaxation loss. And last sixth one is the relaxation loss. It is nothing but a creep in steel. Okay. So relaxation loss is 62.5 in both the cases. Okay. So we have listed out all these losses related to the post tensioning and pre tensioning conditions. So let us add all these losses, so you get the total losses. Okay. Add these losses. So 22.50 plus 21.87 plus 45.15 plus 29.93 plus 62.50, total is 181.95. Okay. So this is the total loss in post tensioning members. In pre-tensioning, 38.88 plus 63 plus 61.23 plus 62.50. So this is 225.61. So what are the percentage loss? How it is calculated? The percentage loss is calculated as total loss 181.95 divided by initial pre-stress. Initial pre-stress is 1250 multiplied by 100. Okay, so it is 181.95 divided by 1250 multiplied by 100. So the answer is 14.55% percentage loss in post tensioning. Same thing you have to do in this case. So percentage loss is, total loss is 225.61 divided by initial pre-stress is 1250 multiplied by 100. Okay, so 225.61 divided by 1250 multiplied by 100. The total percentage loss is 18.04%. So total percentage loss in post tensioning 14.55, and for pre-tensioning it is 18.04. So this is the completion of this problem.